Hey everyone, and welcome. Today, we're jumping into the wild world of real-time analytics. Ever wonder how massive companies can sift through billions of clicks or stock trades or sensor readings the very second they happen? Well, let's find out how it's done. So this is really the big question, isn't it? We've all got this fire hose of data, whether it's from a website, an IoT network, or a financial market, and it's just pouring in nonstop. Waiting for some overnight report to run? That's ancient history. The game now is, how do you query all that information and get an answer back right now? And here's your answer. Meet ClickHouse. It's this incredible open source database that was literally built from the ground up to do one thing: handle a massive fire hose of data and give you answers with insane speed. We're talking logs, IoT events, you name it. It's all about powering those real-time dashboards that so many businesses rely on. All right, so here's our game plan. First, we're going to talk about why we even need this kind of speed in the first place. Then we'll get into what ClickHouse actually is and uncover its secret sauce. After that, we'll walk through a really cool real-world example. And finally, we'll wrap up by exploring some other powerful use cases. Let's do it. Okay, first up, the need for speed. I mean, why can't we just use the trusty old databases we already know and love, like a MySQL or a PostgreSQL, for this kind of work? What's the problem? Well, it all comes down to specialization. It's about using the right tool for the right job. See, databases usually fall into one of two camps. On one side, you've got OLTP, which stands for Online Transactional Processing. Think of these as your day-to-day workhorses, perfect for quick, simple tasks like creating a new user account. But on the other side, you have OLAP, Online Analytical Processing. These are the heavy lifters, built to handle super complex questions across millions or even billions of rows. And ClickHouse? Yeah, it's an absolute beast in that OLAP world. So, if ClickHouse is an OLAP database, what makes it so ridiculously fast compared to others? Well, the biggest reason is right in its foundation. It's built on something called columnar storage. This visual right here explains it perfectly. Your traditional database is row-oriented. It stores everything about a single record, like an employee's ID, name, and salary, all together. So if you just want to calculate the average salary, the database has to scan every single piece of data for every single employee. So inefficient. But a columnar database like ClickHouse flips that on its head. It groups all the salaries together, all the names together, and so on. So when you ask for the average salary, it literally only reads the salary column. That is a massive reduction in the amount of data it has to scan, which is why it's so incredibly fast. But okay, columnar storage is just the beginning. Now we get to the really cool stuff, ClickHouse's secret sauce. A couple of super powerful features called the merge tree engine and materialized views. The merge tree engine is really the beating heart of ClickHouse. You can think of it like a hyper-efficient librarian who's constantly working in the background. As new data comes in, it takes it in small batches, sorts it, and then cleverly merges those batches into bigger, perfectly organized chunks. This whole process keeps your data primed and ready for lightning-fast queries at all times. And this is the second piece of magic. Now, if you've used other databases, you probably think a materialized view is just a snapshot of data that gets refreshed every once in a while. Well, in ClickHouse, you can just throw that idea out the window. Here, a materialized view acts like a real-time trigger. The moment new data shows up, the view kicks into action, processes it on the fly, and fires the result into another table. It's not just a cache, it's a living, breathing data transformation pipeline. All right, enough theory. It's cool, but let's see how this stuff actually works in the real world. We're going to build the analytics backend for a super high-traffic URL shortener. So here's the architecture. Follow the data with me. Every single time a user clicks on a shortened link, an event gets fired off to a message queue, like Kafka. A stream processor, in this case Apache Flink, immediately grabs that event and shoves it into ClickHouse. Then, our Analytics API can query ClickHouse and get up to the millisecond insights. So, how do we actually build this in ClickHouse? Step one is kind of genius. We create a table called raw click events, but look at the engine. Null. Now you might be thinking, a table that doesn't store any data? What's the point? Well, it's clever. It acts like a pipe, or a funnel, just a simple entry point for our data stream to flow through. Okay, step two. We create the table that will actually hold our data. Click stats hourly. And the engine here is the real key. Summing merge tree. This is an awesome version of merge tree that automatically looks for rows with the same primary key and just sums up their metrics for you. It's doing pre-aggregation right inside the storage engine itself. And here's the glue that connects it all, the materialized view. This is that real-time trigger we were talking about. It just sits there, watching our raw click events pipe. The second any data flows in, it wakes up, runs this aggregation query, and inserts the nice clean results directly into our click stats hourly table. So this diagram sums up this whole pattern beautifully. Raw data streams in, it passes right through that null table, the materialized view instantly grabs it and does the math, and only the final summarized results actually get stored. We never even have to store the raw click events, which saves a ton of space, but we still get our stats in real time. It's incredibly efficient. And this right here, this is the payoff. When our boss asks for the top performing links, we run a dead simple query like this one. And because all the heavy lifting was already done when the data first arrived, this query comes back in milliseconds, even if it's summarizing what was originally billions and billions of clicks. See? That's the whole point. With ClickHouse, you do the hard work on the way in, so your queries on the way out are effortless and fast. A URL shortener is just one example, of course. ClickHouse is a total game changer in a bunch of different industries, so let's do a quick fire round of a few more. First up, log management. We all know applications can generate just mountains of log data. ClickHouse is absolutely perfect for this. It has amazing data compression, and it gives you the power to search through terabytes of logs in just seconds. So with a simple query like this, a developer who's on call can instantly figure out which microservice is throwing the most errors in the last hour. Being able to slice and dice huge volumes of logs in real time like that is absolutely critical for troubleshooting. Next up, the Internet of Things, or IoT. Just try to picture millions of sensors on factory floors or in smart homes, all streaming data every single second. ClickHouse can handle that fire hose of data with no problem, running real-time aggregations for dashboards and alerts. You want to know the average temperature per hour across all your devices? A query like this gives you the answer right away. This allows engineers to track trends and spot problems the moment they happen, not hours later. And finally, let's look at the super high-stakes world of financial markets. Here, you have to analyze every single trade, every quote, processing billions of events with practically zero latency. ClickHouse is actually used to power the trading algorithms and analytics that give these firms their competitive edge. So let's wrap this up. We've seen how ClickHouse's pretty unique architecture makes it an absolute powerhouse for any kind of real-time analytics. And let's be honest, the amount of data we're all generating isn't slowing down. It's only getting faster and bigger. Which really just leaves one final question you have to ask yourself. Is your analytics engine ready for it?